Hi, my name is Matthew, and today I will be teaching you about order of operations. Order of operations is just a set of math rules that tell you which math operation, like addition, subtraction, multiplication, or division, you do first. Well, you might be wondering, why do I need rules to tell me which operation I do first? Can't I just do them in any order I want? The answer to that is no, for your solution will be incorrect if you do so. The order of operation rules are a way for us to agree on the order you should do math operations in. So, if we always do the operations in the same order, then we'll always get the same answer. Now that you know why we need the order of operation rules, let's find out what those rules are. There are basically four of them, and they go something like this. First, do operations in parentheses and brackets. Parentheses are these symbols that curve forward and backward and are used in pairs like this. When we put numbers and operations between them, it forms a group. Brackets work exactly the same way. They just have a shape that looks a little more boxy. Next, do exponents. Exponents are a way of writing repeated multiplication. For example, 4 by 4 by 4 can be written as 4 to the third power. The small number is the exponent or power, and it tells you how many times to multiply the base number together. Then you do multiplication and division, and lastly addition and subtraction. These last rules are important because they deal with the most common math operations: addition, subtraction, multiplication, and division. The rule says that we do multiplication and division before addition and subtraction. When you see a problem with both multiplication and addition, you will do the one that comes first from left to right. The same with addition and subtraction. The one that comes first, from left to right. Let's do an example. 8 plus open brackets 2 times 5 close brackets times 3 to the fourth power divided by 9. You're going to do the first step, which is parentheses. So 2 times 5 gives you 10. Next, you're going to bring down everything and continue with step 2, exponents. 3 to the fourth power equals 81. Now you're going to do multiplication and division from left to right. First comes the multiplication. 10 times 81 equals to 810. Then division. 810 divided by 9 equals 90. Lastly comes addition. 8 plus 90 equals 98. And that's your final answer. Now we're going to move on to law of indices. Indices are used to show numbers that have been multiplied by themselves. They can also be used to represent roots, such as the square root and some fractions. The law of indices enable expressions involving powers to be manipulated more effectively than writing them out in full. An index or power is a small floating number that appears after a number or letter. The plural of index is indices. Indices show how many times a number or letter has been multiplied by itself. If you look up the law of indices online, you'll probably see a long list of equations that looks something like this. It's kind of overwhelming when you see them all at once, but don't worry, we'll take them one step at a time, and you'll see why they are not all that complicated. We will start with law 1, which is the product law. A to the m power times a to the n power is equal to a to the m plus n power. So 2 to the second power times 2 to the second power is equal to 2 to the fourth power. The base number can be joined only if they are the same. This is pretty easy, right? Moving on to law 2, the quotient law. A to the m power divided by a to the n power is equal to a to the m power minus n. To illustrate this, 3 to the 6th power divided by 3 to the 4th power is equal to 3 to the 2nd power, because 6 minus 4 is equal to 2. Now comes law 3, the power law. Open brackets, a to the m power, close bracket, to the n power equals to a to the m minus n power. So 2 to the 4th power in brackets to the 2nd power is equal to 4 times 2 equals 8. So the answer is 2 to the 8th power. We are all the way at law 4, which is the zero exponent law. This law states that a to the 0 power is 1. So anything raised to the 0 power will always equal 1. Example, 3 to the 0 power equals 1. Now I'm going to pass over the mic to my colleague to proceed. Thank you.
Hello, Danica here, and I will be moving on to rule number 5, the power of a product. For any real numbers a and b and any integer n, the law states that a times b to the power of n is equal to a to the power of n times b to the power of m. So let's say that you have 3 times 2 to the power of 3. You're going to write it out as 3 times 3 times 3, which is going to be 27. Then 2 times 2 times 2, which is going to be 8. And you multiply 27 times the 8, and you should get 216, which is going to be your final answer. Rule number 6 is the power of a quotient. This law states that a over b to the nth power is equal to a to the nth power divided by b to the nth power. So if you have 3 divided by 2 to the 3rd power, it's going to be 3 to the 3rd power divided by 2 to the 3rd power, and your answer should be 27 over 8. Lastly, rule number 7 is negative indices. It states that a to the negative m power should be written as 1 over a to the mth power. If you have 1 over a to the negative m power, that should be written as a to the mth power. For example, if you have 3 to the negative 2nd power, you're going to write it as 1 over 3 to the 2nd power. The best way to understand how this works is to practice. So let's work an example together. You have 7 to the 2nd power times 7 to the 3rd power all over 7 to the 4th power. First, you're going to start with law 1, whereby you're going to add the powers of a multiplication. So 7 to the 2nd power times 7 to the 3rd power is going to give you 7 to the 5th power, because 3 plus 2 is equal to 5. Then you're going to bring over the 7 to the 4th power. Now you have 7 to the 5th power over 7 to the 4th power, and you're going to utilize law 2, which states that in division you're going to subtract the powers. So 5 minus 4 is equal to 1, which brings you to your final answer, which is 7 to the 1st power. The next topic is polynomials. Before we can understand what polynomials are, we need to learn about what mathematicians call terms. Terms are mathematical expressions that are made up of 2 different parts: the number part and a variable part. In a term, the number part and the variable part are multiplied together. But since multiplication is implied in algebra, the 2 parts of the terms are usually written right next to each other without the multiplication symbol. The number part is referred to as the coefficient and is usually any number like 1, 2, 3, or 4. The variable part is the letter and is usually x or y. Terms can have any number of variables, but most of the time when dealing with polynomial, you only need to deal with one term and you'll have one variable. Or maybe if the problem is complicated, it's going to be two terms. You should note that the coefficient always comes before the variable. It's conventional to always write the number part before the term. So, for example, you're going to write 6y instead of writing y6. Let's see how the basic idea of term helps us to understand the basic idea of polynomial. A polynomial is a combination of many terms. It's kind of like a chain of terms that are linked together using addition or subtraction. The term themselves contains multiplication, but each term in a polynomial must be joined by addition or subtraction. Polynomials can be made from any numbers of terms joined together, but there are a few specific names that are used to describe polynomials with a certain number of terms. If there are just two terms, we refer to it as binomial, since bi means two. If there are three terms, it's going to be called a trinomial, since the prefix tri means three. Beyond three terms, we usually refer to it as polynomial, since poly means many. And in fact, it's common to simply use the term polynomial, even when there are just two or three terms. So the basic idea of polynomial has been covered. The degree of a term is determined by the power of the variable part. For example, in this term, since the power of the variable is 4, we can say that the degree of this term is 4, or that it's a 4th degree term. And in this term, the power of the variable is 3, so it's a 3rd degree term. Likewise, this would be a 2nd degree term, and this would be a 1st degree term. Suppose you have a term with no variable. It's just referred to as being a constant term. When you have terms with more than one variable, in that case, you add up the powers of each variable to get the degree of the term. Since the powers in this term are 3 and 2, 3 plus 2 is equal to 5, so this is a 5th degree term. Polynomials are set in order of their degree. It goes from highest to lowest. For example, 4x to the 3rd power plus 8x to the 2nd power minus 3x plus 4. You can see that the power is arranged from highest to lowest.
That brings us to the end of our presentation. Thank you for watching, and we hope that you enjoyed.